you for inviting me here to speak today. And topic of my talk announced. So I want to talk about ARPE19 cell and model for normally aging RPE. Okay, so I would like to start with a little bit of introduction on lipofuscin. And it accumulates normally in RPE with age. So if you look here on A panel, it's a little bit of autofluorescent material in micrographs section of retina from 26-week-old rat, and on B is 117-week-old albino rats. So we have this accumulation of lipofuscin normally with advanced age in rats and in human. But also, we have this lipofuscin accumulation, which is implicated in pathology of several retinal degeneration diseases, as VMD, Stargardt macular dystrophy, and AMD. So also, accelerated accumulation of lipofuscin in RPE precedes visual loss in the Stargardt's patient. And Stargardt's is considered to be juvenile form of AMD. So now A2E, it's already was talked a little bit by first speaker about A2E, that A2E, its oxidation products are major components of lipofuscin in RPE. Now, this is a structure, and it's produced from 2 molecules of vitamin A aldehyde, retinal, and 1 molecule of ethanol amine. So why I'm going into details is because we have normally aging RPE with accumulation of A2E, and we have pathology and accumulating of A2E. So what's the difference? Like, why most of the people go with accumulating lipofuscin without pathology developed? So A2E is byproduct of the visual cycles, and then accumulates in RPE lysosomes. So here on the left, you see visual cycle with rhodopsin, light, all transretinal, and regeneration back to 11th. And so it's widely accepted that A2E formed from all transretinal, but recently also 11th retinal was proposed to be the source. So on other side, even it's coming from this side of visual cycle, it's still byproduct. And majority of A2E fed to the RPE accumulated in lysosomes. But here again, one problem that you can observe striking drop in latency of the lysosomes at concentration above 2 micromolar A2E, so which is called A2E leakage. So at low level of A2E accumulation, you have effects on lysosome, but at high accumulation, you will get detergent-like activities of this molecule, and you'll get leakage from lysosomes and actually disrupting of lysosomal membrane and mitochondrial membrane, which will lead to apoptosis. So by Clara Mitchell, several years ago, was shown that pH is increased in lysosome from RPE of ABCA knockout mice, ABCA4 knockout mice. This is protein which is causal for Stargardt macular dystrophy. So it's knockout animal model for Stargardt disease. And if you look at pH, you see significant increase. And with aging, increase only getting bigger. And then she was able, with CMP activating mix, to normalize pH to normal level. Why we are interested in that? So what's happening that when you alkalinize lysosomes, you disrupt outer segment clearance. And one of the most important functions of RPE, normal RPE, is uptake, phagocytosis, and degradation of outer segment material. So this outer segment is getting shed all the time, and RPE is digesting this material. So when we alkalinize lysosomes of RPE, this digestion get impaired, and you have accumulation of lipofuscin material in RPE. So what she was able to show in ARPE19 cells, which is human RPE cells, that with low doses of A2E, with chronic treatment, you can increase in lysosomal pH quite significantly. And with this treatment of CMP analog, you restore pH and you restore clearance of outer segment in this ARPE19 cells. So, unfortunately, we have quite a lot of conflicting data in literature about that. So on one side, we have low concentration of A2E, which affect lysosomal function, increase lysosomal pH, inhibition of ATP-driven proton pump, and impaired degradation of outer segment. But on another side, some of the studies reported no connection between A2E accumulation and pH changes. And what could be the explanation? So if you look at details of studies, we can see that here, where people see no connection, it's much higher concentration of A2E. And as I already told, it most probably you have other effects that lysosomal effect. It's already disruption of different membranes, like mitochondrial and going directly to apoptosis. So what we wanted to do is to develop aging RPE model using long-term feeding with low doses of A2E. We just want to see lysosomal effects on RPE cells. And important outcomes we are looking for is that accumulation of A2E in lysosomes, increasing cell stress without cell death. So it's very important for us to distinguish between apoptotic effects of A2E, because at high concentration it just works as poison. And most probably what's happening in Stargardt, but not in AMD, because we all accumulate a lot of A2E with age, and not all of us develop AMD. So we don't want to look at poisonous effect of A2E. So modulation of lysosomal pH, so would we see it? Efficiency of lysosomal enzyme, outer segment processing, and what will we see, degeneration or cells or compensatory effects? And key points for this physiological RPE model shown here. So first of all, we use ARPE19 cells 3 weeks after reaching confluence. So it's differentiated post-mitotic with tight junctions, which we confirm. We use scheme of multiple feeding of A2E, again low doses. We added it under yellow light condition, which is around 60 lux, so it's very dim light. It's left overnight on the cell every time. And we looked through different concentration of A2E and looked for localization, toxicity, even in the presence of different concentration of stress stimuli. So we try to see not only that we don't see apoptosis, but also that cells do not become more sensitive to stress in this presence of A2E. So we use non-pro-apoptotic concentration of A2E. Okay, so if you look at 10 micromolar A2E and we feed that to our cells, this is lysotrackers, this is A2E. It's partial colocalization. So most probably this concentration already leads to leakage and disruption of membranes. On another side, look at that. So this is stress stimuli, hydroquinone, and it leads to cell death, cell stress, and then cell death. So we're looking at behavior of cells at different concentration of A2E. In control, low level of this stress material doesn't lead to cell death, but high level, yes, leads to cell death. If we use it in presence of low level of A2E, and this is multiple feeding of this concentration, up to 1 micromolar, you still see behavior similar to control cells. At 10 micromolar, you'll get cell death. So the highest concentration we can use for our experiment is 1 micromolar. Now, at this scheme, we fed 5 times ARPE19 cells during 3 weeks, 1 micromolar A2E. We isolated lysosome fraction, and we looked for A2E fluorescence. A2E is autofluorescent, so at this condition, you can just see it in lysosomal fraction. So you see LAMP1 marker in lysosomal fraction for blank and A2E-treated, and you can see A2E in lysosomal fraction. So yes, it accumulates in lysosomes. if you look at single feed ARPE19 cell and just extract A2E from cells, this is standard, this is extracted, you can see some accumulation and you can see quite a lot of oxidation. And with multiple, even more. So yes, A2E is there, and it's isomerized, definitely, because it's still yellow light. So you have isomers, and you have a lot of oxidation going on. So when we say we treat with A2E, not all A2E stays A2E. So it's A2E plus oxidation products. And yes, pH is changed, but not that pronounced as people saw before. In our system, we could see only 0.13 units pH change at 1 micromolar. This is multiple treatment again, and 0.25 at 10 micromolar. So lysosomal effect not that large, but we definitely see effect on also enzyme activity, and it's degradation enzymes, cathepsin D and acid phosphatase. What we didn't expect, but what we saw actually is that impairment in lysosomal enzymes activity only in specific activity. So it means if you normalize the amount of protein, specific activity goes down. But total activity in lysosomal fraction goes up. So cells actually produce more lysosomes, more proteins, and total activity is not affected, it's even improved. So you have some compensatory effect. And it's saved here. So other thing we didn't expect to observe, but what we observed is melanization of cells. So ARPE19 cells in these conditions, they grow without pigment. To get them to develop pigment, you need to grow them in presence of sodium pyruvate. But if you grow without sodium pyruvate, even they are differentiated, they grow for a long time, they're not pigmented. Now, if we treat them with A2E and then challenge without the segments, they develop pigmentation, quite pronounced. You can see it just visually, and on mass spec, you can see really well the spectrum, but it has peaks which masses I show here, and you have this plus 14 series. When melanin degrades, you have loss of CH2, so it's normally showing this 14 series. Also in the same fraction, you can see presence of A2E. It's 592 is A2E mass, MZ ratio, and 608 is furan form, so it's oxidized form in each major. Now, if you do spectral analysis of melanin and A2E in this lysosomal fraction, you can see that in original fraction you see mostly A2E. In later fraction you see more melanin, but at some of them they go together. So you have melanin and A2E in the same lysosomal fraction. Also, you cannot see it very well, you have presence of a melanization marker in the lysosomal fraction, MEL17 and TRP1. TRP1, one of the enzymes which produces melanin, one of the reaction, and you can definitely see increase in A2E-treated cells. Now, when we looked at outer segment degradation, you can see we probe for rhodopsin. So it means if outer segments got phagocytized and degraded, you will not see rhodopsin in this lysosomal fraction. So the better degradation, the less rhodopsin you can see. Now we see even less in A2E-treated cells than control. So we have compensation. So in our system, it's not impaired. Even enzymatic activity is, specific enzymatic activity is impaired, but not clearance ability of these cells. So I just want to stop on conclusions that we developed physiological model, cell model for aging RPE, post-confluent ARPE19 cell, multiple treatment with non-prop apoptotic concentration of A2E and outer segment challenge. A2E in our system led to mild alkalinization of lysosomes and impaired specific catalytic activity of lysosomal enzymes. And however, ARPE19 cells are able to compensate for the lysosome alkalinizing effect of A2E by production of melanin and melanolysosomes. So we call it hybrid melanolysosomes. Right now, we are doing electron microscopy to figure out what kind of organelles is that. And outer segment clearance in pigmented A2E-treated ARPE19 cells is not impaired. So what we hope is that based on this physiological cell model of aging RPE, we can induce changes leading to MD-like phenotype. So what we clearly show is that in this cells model, RPE can compensate for low-level chronic accumulation of A2E. It's what's happening in our normal eyes with aging. So now if we will tweak some changes and induce some changes, we hope to see how we go from normal physiology to pathology. And last, I just want to give acknowledgement to Natalie and Brian Brooks, who was instrumental in developing cells, my student Toril and Bianca, Dr. Redmond, lab chief where I work, Aparna Lakaraju, our collaborator from University of Wisconsin, and Craig Thomas in MCAS for A2E synthesis. And thanks a lot. And open to questions.
Thank you very much. The paper is open for questions. We have time for perhaps one question here.
Mm-hmm. Thank you. Could you go a little bit? Uh-huh. Yes, yes. So actually, dogma is that all our melanogenesis and RPE happens prenatally, and then we only lose melanin. And electron microscopy we are doing now with Ulrich Schreiner from Germany, who for 20 years tried to convince people that we can induce melanogenesis in our eyes. And he showed all kind of mechanisms for that, but didn't have physiological idea how it's happening. So what now we're showing is that A2E leads to induction of melanogenesis. So we're trying to see if it's actually in aging model, because you lose some of the melanin, you start to lose compensatory effects to A2E accumulation.
Thank you.